All right, everyone, welcome to another Mr. Golden Stuck at Home video. This video will hopefully not be quite as long as the last one, but it will still be pretty detailed. Please make sure you're paying full attention. Make sure you're pausing on the you-dos, and make sure you're doing whatever it takes for you to learn and master this material. Our objective today is that students will be able to create a linear equation, graph, and table when given a story. So we're only going to give you a story, and we're going to expect you to create the equation, graph, and table that match it. Remember, we can show mathematical relationships in any of these four ways: a story, equation, graph, or table, and it doesn't change the meaning. It's just changing the form. Just like when I change water to ice, it doesn't change the chemical makeup, it just changes how it's presented. So let's move to example one. Our example one here is that Madison has $50 in her bank account, that every week she earns $10. So when I'm given a story, the first thing I like to do is create the equation. So Madison's got $50 in her bank account. Every week she earns $10. She's earning the same amount each week. So I know this is a linear equation because it has a constant rate of change. And I know that my equation for linear equations or linear functions, whatever you want to call them, is y equals mx plus b, where b represents the y-intercept or the beginning, and m represents the rate of change. And so let me find that information. It says she has $50 in her bank account right now. That's where she starts. So I can actually just write that plus 50 right underneath the b, the beginning, because that's where she starts. So I'm creating this equation. Every week she earns $10. How could I turn this statement right here into an algebraic expression? Well, I know it's $10 per week. So every week she earns $10. So I do 10 times weeks, right? The amount of money she has is 10 times the amount of weeks. If it's 2 weeks, I do 10 times 2, that's 20. I did 3 weeks, that's 10 times 3, that's 30. So I'm doing 10 times the amount of weeks. But 10 times the amount of weeks, I don't want to write that all out. So I could use a variable that represents weeks. And I could use W, right? W could represent the amount of weeks. So I could do this as just simply 10W. 10 times W. It's a coefficient. We know that represents multiplication. And I can write that here. 10 is my M. It's my rate of change. And now W is my X. That's the time. Independent variable. All right, so now I just need a variable that represents my y. Well, I know we're talking about money here, so I could use like a dollar sign to represent the total here, or I could use like M for money. I don't care what we use. I'm going to use M. So M now stands for money, Madison's money, and W stands for the amount of weeks that have gone by. And now I have an equation. Madison, total money, M, is equal to 10 times the amount of weeks plus 50. And this equation makes sense if I think about it, right? If I said, how much money does Madison have after 4 weeks? Well, you could plug in a 10, or you could plug in a 4 for the amount of weeks, right? Because now weeks is no longer an unknown. Variables only represent unknown numbers. I know, it's been 4 weeks now. I just told you that. So to figure out how much total money M she has, I do 10 times 4 is 40 plus 50. And after 4 weeks, Madison would have $90, right? So the equation just helps me figure out some real world scenarios here. So now I have an equation. Let me erase some of this stuff here. I have an equation, but I'm asked to come up with a story, table. I'm given the story. I'm asked to come up with an equation, table, and graph. So now I'm going to make my table next. I didn't give you a table because you need to get kind of used to making these T-charts. So I'm going to make a table where I have, what's my X? My X in this situation is W, so it's going to go first. And money is my M. I want this table to show, let's do 3 points. Let's do 3 points where I tell you the amount of weeks and you tell me how much money she has. So let's write a 0, 1, and 2. So after 0 weeks have passed, I could plug in a 0 right here. I could do 10 times 0 plus 50, right? That's how I would calculate that. Or you could just think about it. If 0 weeks have passed, she hasn't earned any money yet, but she started with $50. So after 0 weeks, her money is $50. Now after 1 week, she earns $10, right? So now I just need to go up 10. So after 1 week, we go up 10. She now's got $60. If I wanted to show that mathematically, I just do 10 times 1 plus 50. 10 times 1 is 10. 10 plus 50 is 60, right? We could plug that in. See how this is all connected. The equation can be used to find the points on the table. Everything's connected. It's all the same thing. Lastly, I could do the last one. I'm going up 10 each week. So she was at 60 after week 1. Now she's at 70. All right. And so if you wanted to show that mathematically, you could do 10 times 2 weeks plus 50. 10 times 2 is 20. 20 plus 50 is 70. It all works out. All right. So now I have my table. I have my table to go with my equation. The last thing I want to do is a graph. And there's 2 different ways we could do the graph. I'm going to show both. All right. Make sure you kind of understand both here. First way I could do the graph is I could look at my equation. Here's my equation. All right. I could start at 50 because I know this is the b, and I know the slope is 10 over 1. So I could go, let's say these are going up by 10. You need to get used to taking a blank chart and figuring out what the intervals are here. I'm going to go 10, 20, 30, 40, 50. So this is going to be 50 right here. All right. And so that's my first point, the b. To get to the second point, I use the slope. The slope here, m, is equal to rise over run. And so that 10 could just be 10 over 1. So this could say go up 10. And remember, these are in intervals of 10. So this is 60. So up 10 really just goes to here over 1. And I can make this chart, right? And I could even label my axes. Like I know that the y-axis, because this one in m goes in for y, is her money. And the x-axis, w, because it's weeks. So this chart is showing me, let me move myself out of the way for a second. It's showing me a lot of the same it's showing me all of the same information that I'm seeing in the table and the equation. After 0 weeks, 0, I have $50. After 1 week, I have $60, right? After 2 weeks, I have, what would go here? 70, right? Because it's going up by 10 each time. See how I'm getting the same information from this table I'm getting from the graph? They're the same thing shown differently. Let me do a little bit of erasing. Show you the other way I could create the table. The other way I could create the table is to create a table, or to create a graph, to create a graph, all I need is 2 points. Any 2 points can be connected into a line, right? Well, guess what? This table over here, these are points. Like these pairs, these are just ordered pairs that can be graphed. So I could go to, again, I could say I'm counting by tens here. I could have a point here, right? That's 0, comma 50. That's a point. I go to, let's say I chose this point as my second point. I could go to 2, comma 70. It doesn't matter which point. Put a point there. Now I have 2 points. Any 2 points can be connected into a line, and I have a graph. So look, I have everything I need. It's a little messy. I got stuff everywhere. But look, we have shown all 4 ways in one place. We have the story, the original story here, right? Madison has $50 in her bank account. She earns $10 each week. I have an equation that represents that same exact story. Her total money is equal to 10 times the amount of weeks plus 50. These are the same things shown differently. I have a table that shows how much money she has at each week. After 0 weeks, she has $50. After 1 week, she has $60. After 2 weeks, she has $70. I have a graph that shows the exact same thing. After 0 weeks, she has $50. After 1 week, she has $60. After 2 weeks, she has $70. These are all the exact same thing. They're showing the exact same thing, just in different ways. Hopefully this is starting to really make sense. All right. Let me clear this all out. And it's time for you to try the you-do. Again, please pause and try it on your own first. It's the only way you're going to get better. If you simply copy down what I write, you will not improve your math. The whole point is to learn, not complete our work. Okay. Hopefully you've been paused and you're completing it on your own. We're going to solve this you-do on our own here. We're going to go over it now. The river is 60 feet deep. During the summer, the river dries up and shrinks by 1 foot per week. All right, so I can see it's changing by the same amount each week. So that means I have a constant rate of change, which means it's a linear function. Y equals mx plus b is our equation. Now I can tell that I begin here at 60, right? A river is 60 feet deep, so I'm going to start at a positive 60. And it is shrinking by 1 foot per week. Every week, it goes down 1 foot. So I could write that as -1 times weeks, right? Down, that's shrinking. That's why it's a -1. But really, I could use a W to represent weeks, a W as my variable. And we could write that as -1 W. And so all of this equals the depth of the river. The depth of this river is equal to -1 times the amount of weeks plus 60. So hopefully you got this as your equation, right? This is a skill we should have had coming into this video, being able to create the equation. The only difference here is we didn't give you the variables. You had to come up with them on your own, right? And I think that kind of makes you understand this a little deeper. All right, instead of doing the table this time, I'm going to do the graph. It doesn't matter what order you go in, just to show. Let's say again that we're counting by tens here, so that this is 10, 20, 30, 40, 50, 60, all right? And that tells me where to begin. I have my b, my y-intercept. We should already know how to graph lines. Given an equation, we should know how to graph a line. So I can put a point here right at 60. Put a point right here at 60. And then this is my slope. My slope is rise over run. Well, that's a -1, but I can put anything over 1, right? It doesn't change. -1 divided by 1 is still -1. Again, didn't change the number, just changed the form. So I go down 1 over 1. This is actually where it gets a little bit tricky because we're going down by tens on this side. So let's just also go by tens on here. So each step here is 10 weeks. So that we can go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Let me get myself out of the way here. I could even fill these in. That's 30, 40, 50, 60. So I can connect these into a line. See if I do a good job. All right. And now I have a line. This line represents the relationship between how many weeks have passed and the depth of this river. Eventually, you can see I get to this point right here. After 60 weeks, the river is completely dried up. Right? It's at a depth of 0. It's completely dried up. We'll talk more about those kind of questions in the future. All right. Now I need my table. My x is weeks. My y is the depth. I'm just going to go 0, 1, 2. I know at 0 weeks that the depth is 60, right? Because it hasn't dried up at all yet at 0 weeks. So I know that the depth is 60 after 0 weeks. If I wanted to figure out, well, it goes down 1 every week. So I just need to go down 1, right? This is where we got to let common sense overtake having to do any math. Sometimes if we just use common sense, we don't have to do any math, which is pretty nice. Goes down 1 every week. Goes to 59. Goes down 1. Goes to 58. Right? There, I have a little table that shows the relationship here. All right? Here's the table. I've got all 4 ways now. I've got a table. I've got a graph. I've got an equation. I've got a story, all showing the same thing. that there is some river that starts at 60 feet and goes down by 1 foot per week. They're all saying the exact same thing. I think the graph is the hardest part for y'all since you aren't given the intervals. That's maybe a skill that you need to work on, coming up with the intervals for a graph. All right, let's do another example. This turns out is probably going to be a video just as long as before, maybe 25. We'll see. You'll know by the time you're watching this how long it is. I don't know how long it's going to be as I record it. Ramir starts a business selling hot dogs. His business starts $3,000 in debt. Each hot dog he sells profits $2. All right. This is going to be a tricky graph. I already know that. Put me right here. Okay. So first step, I want to come up with the equation. So I know it's a constant rate of change. Y equals mx plus b. His business starts $3,000 in debt. Debt means negative, so I know my beginning is negative 3,000. And he earns $2 per hot dog. So $2 per hot dog. I could write as 2 times the amount of hot dog. Or I could say H stands for hot dog, and I could write that as 2H. And it's a positive 2H because he's making money. I can fill that in right here. And all of this is equal to his profit. So I could use a P for profit. It's a P. All right. Okay, so now I have my equation. I need to make a table. Gonna make my table here. Boom. And so how many hot dogs he sells and what's his profit? Well, his hot dogs, if he sold 0 hot dogs, I know his profit is negative 3,000, right? Because that's where he starts. And if he doesn't sell any hot dogs, his profit's not going to change. Well, if he sells 1 hot dog, I could do 2 times 1 minus 3,000. Like that's how we would solve this using the equation. 2 times 1 is 2 minus 3,000. Or I could just say, look, he gains $2. So if he was at negative 3,000 and gains $2, well, what's negative 3,000 we go up to? It's going to be negative 2,998. If he sells 2 hot dogs, it'll be negative 2,996. Just going up 2 each time because that's the slope. That's the rate of change. So now I have a table here. Could even fill in some other parts of the table. Could say like, well, if he sells 1,500 hot dogs, then he'll break even. He'll be at $0 in profit. He won't be in the negatives anymore. That's called a break-even point in business when you've made $0. And so then every hot dog he sells after that, he'd be earning a profit. Graph's going to be pretty tough for this one. So we're going to start at negative 3,000. So let's just say that these are down by 1,000. So this is negative 1K, negative 2K, negative 3K. Start here at negative 3K. And let's just try to make this a 1-for-1 or a 1-for-2 deal here. So let's just say that these are also changing by 1,000. Again, if I should probably have started us off with some graphs where you don't have to make this. So I won't worry too much about your graphs yet. But we're going to go up 2 because the slope is positive 2. Up 2 over 1. Up 2 over 1. And kind of have my graph here. I'm not going to get, in fact, in the next one on the you do, don't even want you to make the graph. So let's not worry about the graph for this one. So you put an X on the graph. I want you to pause. Try the you do on your own to make make an equation and a table. All right, hopefully you're unpausing because you tried it. I'm going to go through this really quickly. This video is getting much longer than I want it to be. Candle is 12 inches tall. Every hour it burns, it decreases half an inch. It's changing the same amount each time, so I know that's a constant rate of change. It's y equals mx plus b. It begins at positive 12, and it decreases half an inch per hour. So it's decreasing 1/2. You can write that as negative 1/2 h since it's per hour. And we could use I for inches here. how many inches the candle is. All right, so I is equal to -1/2 h plus 12. That's my equation. I want to make a table really quickly where h is the amount of hours and I is the inches of the candle. Obviously, after 0 hours, the candle is 12 inches tall because it hasn't burned it all yet. But after 1 hour, it's gone down half an inch. So if I start at 12, I go down a half, I'm at 11.5. After 2 hours, it's gone down another half. If I'm at 11.5, I go down another half, so 11. It's going to go down and down and down all the way after, 24 hours? After 24 hours, it would reach 0. The candle would burn completely out after 24 hours if you left the candle burning all day. All right. There are some practice problems for you to try. This is a harder lesson. We'll work on it together when I get back. Good luck, and I hope you're really working your hardest to learn.